Hello everyone. Here in this presentation, we're going to explain and elaborate on the 5G core network, its different network functions, the interfaces between these network functions, and their functionalities. Now, we're going to also touch a little bit on 5G signaling. Okay, so basically, and here let me select the laser. Okay, so we're gonna touch on the core network part of the 5G architecture, not the air interface frame structure. So it's basically the internal network. So what are the different specifications of a 5G core network? Okay, what's a 5G core network? It is basically an evolution from the 4G. Okay, so basically some key functionalities still exist, but they have different network functions with an upgraded architecture, with an upgraded and a more advanced technology. Okay, but some of the things have persisted since the 4G network. Okay, but what are the different and advanced changes, okay, or technological advancements of the 5G network? So basically you have an enhanced mobile broadband eMBB, meaning that you can get to 1 gigabit per second per person, even more, okay, uh, which was basically 100 megabit per second back in the 4G core network technology, okay? So you have URLLC or ultra reliable low latency communications, meaning that it has a frame size of less than 1 millisecond, okay, which is like 0.5 millisecond necessary to send a command, okay, with a very low latency and a high speed, okay, and since it is only a command, okay, like a control command, it won't take much of the resources, okay. This is basically used for communicating with IoT devices, okay, or controlling IoT devices, like remote controlling a vehicle, basically, okay. And MMDC, or maximum mobile telecommunications, meaning that you can fit 1,000 user equipments, okay, which can include IoTs or mobile devices, one per square meter, and it can still cover all these communications, okay. It still carries the capacity to cover all of these devices, okay, and allows them to communicate. So you have a service-based architecture, meaning the network functions are laid out based on the service, okay. Control and user plane separation, meaning you have the control or non-stratum access for the signaling, and stratum access or user plane, which is traffic, okay. So you have a separation between these two. In other words, the control may go via one way and the user plane via another way. So the data traffic would not necessarily follow up the same path with the control signaling data. Why? Because the user plane traffic, which is the data traffic, needs to be as close as the user to allow a high mobile broadband, a faster communication. Meanwhile, the control doesn't require the same thing. Okay, and you have cloud native benefits, which is the network function virtualization. Okay, in other words, these core network devices or equipment that used to have as separate devices, or like physical devices in 4G network, you can have them as virtualized, okay, virtual machines interconnected on the same server, okay, but each one is like a virtual machine, okay, having that specific functionality, and they have a virtual network interconnecting them. So let's go further. First of all, what are the different and main network functions within a 5G network? So basically, this is the core network here. Okay, you have AMF, or application and mobility function. So the AMF, and we will explain those later. So it's basically for handover. Okay, you have the session management function to manage the session or the data session for user equipment. Unified data management, which was the high subscriber, the HSI. Okay, like a hybrid subscriber or a home subscriber service, sorry, HSS in 4G network, or home location register plus VLR in legacy networks. Okay, so this has become the UDM. Okay, you have AUSF or authentication service function. Okay, you have the network resource function, we're going to explain that, and user plane function which connects directly to the user equipment, okay, and reinforces the policy control like the QoS for the user equipment, okay. And these are the different devices that interconnect all these network functions. You have between AUSF and SMF and 10, you have between AMF and SMF and 8 and 11, okay. We're gonna see all that in detail in a little bit. Okay, so first of all, access and mobility management function, or AMF, okay? So access and mobility management function, its main role is mobility, registration, and connection management. The interfaces are N1, connecting the AMF to the user equipment, and 2 to the G node B, and N11 to the session management function. What's the main role of the AMF? So the main role is managing access and mobility of a user equipment, which also includes handover, okay? When the user equipment is being transferred from one G node B to another, the handover management, or even from a tracking area to another, it is the AMF that will trigger the tracking area update, okay? This is where the management of the handover is done. So it also acts as the initial anchor or point of contact when the user equipment is attaching to the 5G core network. It also handles the registration of the user equipment, the connection, reachability, and mobility, which includes handover, but also the access authentication, which is based on the data that the subscriber has in the UDM, which is the Unified Data Management, okay? But it's the AMF that compares the keys of registration, the authentication keys, and the data between the user equipment, or the user equipment SIM card, the USIM, and also the data of that same user, that same subscriber within the UDM. Key functions, so it receives and routes messages from the RAN, okay, from the G node B mainly, back to the core network. So the AMF receives the signaling and the messages from the G node B and sends them back to the internal network, coordinates with security anchor function for authentication, which is what we said moments ago. And also it maintains the user equipment context, meaning whether it's registered or not, and what are the different services that are attached to the user equipment at the moment, and whether these services are active or not. Okay, this is what we mean by context. So it means that the user equipment is now attached or not, and it's connected to these types of services. It's in call. So like even when he hangs up a little bit, the context will remain intact. So if he reestablishes the connection, okay, the context will be like carried through, okay, it will be resumed. Also tracks the mobility, which what we meant by the handover. So when the user equipment is moving between G node Bs or different access types, okay, it will manage that mobility. One key function is updating the tracking area. SMF, or session management function, so it has the responsibilities of session control and IP management, also QoS, or quality of service, which defines the bandwidths that the user equipment has to use or is able to use, okay? It actually sends the QoS. It's not initiated. The QoS policy is not initiated there, but it retrieves the quality of service characteristics and the bandwidth allowed for the user from the PCF. That's why it connects to the PCF via the N7 interface. It also connects to the AMF via the N11 interface, because the AMF will send to it a request for a session, a data session, okay? And also connects to the UPF via the N4 interface. Why the UPF? Because actually when the data is being sent to the user, it needs to cross from the session management function to the UPF before being handed to the user equipment. Why? Because it is the UPF that will enforce the QoS policy, meaning that it is the UPF that will execute the QoS, okay, policy, such as limiting the bandwidth or allowing or blocking the service based on the QoS profile within the PCF. Okay, so now also the role is managing PDU or protocol data unit, which are the data sessions, okay, to put it mildly. Allocating an IP address, so it is basically what you can call a DHCP for the user equipment. So the SMF is the one that allocates IP addresses, okay, and creates and or modify or release a session for the user equipment. So establishing modification or tear down of a data session is done by the SMS function, okay, and that data session is called PDU or protocol data unit. Key functions, so also what are the functionalities? Selecting and interacting with the user plane function, as we mentioned before, because it is the UPF that will force a QoS policy. Managing QoS, session continuity, and roaming. Roaming meaning, because when the user equipment is being handed over, now of course the AMF is the one that manages the handover, but the data session needs in such case to be rerouted to another G node B. So it is the SMF that will reroute, okay, the data session from one G node B to another, okay, and to guarantee a session continuity without an interruption of the data service, okay, and also it manages the QoS, of course, and policy enforcement and interaction with the policy control function. So it interacts with the PCF and will send the policy control enforcement all the way to the UPF. That's where it's at the UPF level that it will be executed. User plane function, so its main role is packet routing, packet forwarding, and inspection of data interfaces. Now the UPF connects to the G node B, which is the final anchor, by the way, before the user equipment. It connects to it via the N3 interface. You have also another interface between the UPF and the session management function, which is the N4, and N6, which is the data network, by the way. And N6 is the interface between the data network and the UPF. So the UPF, the main role is it is responsible for actual data forwarding between the user equipment and external data networks. So it implements user plane processing, including the routing of data, packet inspection and control, and QoS enforcement. Okay, so the key functions, it acts as a gateway to the internet, to the external networks or enterprise networks. It supports traffic shaping, which is traffic control mainly. Okay, so traffic shaping is another word for data flow control or bandwidth control, the sizing of the packets, okay, which is the window size, etc. Usage reporting, so it basically reports back to, let's say, yeah, the SMF, how much, and back to the UDM to update how much the user has used, okay, in terms of not only bandwidth necessarily, but yeah, download size, okay, how much it has used based on the data subscription. So if it is allowed to use, let's say, 40 gigabit per second, 40 gigabits, okay, he has used so far 30, okay. So once it reaches 40, he either is blocked, okay, or he can no longer, like, he needs to be charged, okay, on the units, okay, if he excessively use more than the 40 gigabits allowed, okay. And that reporting, okay, is sent all the way to the UDM to update the status of the user. And lawful interception, okay, decoupled from control functions. Why? Because it's not signaling, okay. The UPF only works with traffic, okay, to allow edge deployments for low latency. So that's why it's decoupled from control functions, because The control can tolerate, so the signaling can tolerate more delays than the user traffic. Why? Because the user traffic needs to have a low latency and a high speed. That's why the UPF are deployed at the edge of the core network so as to reach the user equipment with low latency and high speed, high connection speed. Okay, now speaking of QoS, we present here two major policies for quality control, which are the GBR and MBR. The GBR actually is guaranteed bitrate, and the MBR is maximum bitrate, and we're gonna explain that. So GBR, guaranteed bitrate, MBR, maximum bitrate, are quality of service parameters used to manage and prioritize network traffic. They are particularly important in controlling how bandwidth is allocated to different types of services and users. GBR, or guaranteed bitrate, so it is the minimum bitrate that is guaranteed always, even at dire circumstances when there's so much pressure on the network, when there's so much traffic and so much like congestion. Okay, it is the minimum bitrate that is guaranteed for a specific flow of service. Okay, so it ensures a consistent performance for some critical types of services such as voice calls or video conference, and these are mainly the real-time data transmission applications such as voice calls, such as video streaming or video conferences, which have or need to have a low latency and a minimal jitter. Jitter means like the variation of the delays between subsequent packets. Okay, this is what jitter means. Jitter means that for some packets at times you have a small delay between them, then after that you can have some packets subsequently arriving with much higher delay. This is intolerable for applications such as video streaming. Okay, now the latency is like overall how long does it take for a packet to reach its destination. So examples for GBR use cases: voice over 5G or VO5G, video conferencing, and control systems. So how it works: it reserves resources like the bandwidth to meet this rate, and this resource is guaranteed and is not like distributed with other services. Okay, it's completely dedicated. Even in congestion, GBR can provide a good service by prioritizing the main service and dropping the packets of other or like other non-necessary, non-primordial services. So on behalf of this service, it will only prioritize the critical services while dropping the packets for other excessive services, so as to guarantee the bandwidth for these applications. Meanwhile, MBR, maximum bitrate. Now, as we mentioned, when you have limited resources, okay, bandwidth resources, you prioritize critical services by the GBR policy. But what happens, like, or when it comes to MBR or maximum bitrate? Okay, so let's say you have excessive resources that are not allocated to anyone, and you don't want the abuse of consumption of these resources when the network is not congestion, when like the network usage is very low and the traffic is very low. Okay, so MBR, what it does is it defines the upper limit of bitrate, okay, that the flow is allowed to use even when there's much more bandwidth available. Okay, so that the user won't abuse the network, because he can open up multiple services downloading terabytes. Okay, so the purpose is to prevent a single flow or service or a user, okay, in general, from consuming excessive resources, and which can lock out other users, okay, while he's using these resources, which ensures fairness and network stability. Okay, so primarily the MBR will limit the upper threshold of the bandwidth, while the GBR will guarantee the minimum threshold. Policy control function, or PCF. So it has a centralized policy rules and QoS management. It connects to the SMF or session management function via the N7 interface, and N5 via N5 it connects to the application function, which defines for each application what is the network resources necessary for it. So the role is a central policy engine of the 5G core network, and it determines and enforces rules for quality of service, for charging, so for each bandwidth consumption, for each service, how much charging should be done for each consumption, and or like each month when the user needs to renew the subscription, it is the functionality of the PCF to take care of that. And access control, meaning controlling the access or barring the access for a user equipment, let's say, or for a service. So it generates policy decisions based on the subscription of the user and on subscription info and current network conditions, interfaces with the SMF session management function and AMF to enforce the rules, and supports slice specific and user specific policies. So slice specific means that it's based on a slice of the network on a specific bandwidth allocated for a service or for a user subscription. Authentication server function or AUSF, okay? So the user authentication function handles authentication of subscribers mainly, works in conjunction with the UDM, Unified Data Management, okay, and the AMF. Key functions, it verifies the subscriber's identity using authentication vectors or keys like random keys and secret keys, okay, like the username and password basically, but it's a little bit more complicated for user equipment, and supports EAP, aka authentication method, and credentials management. Now let me go back a little bit for the policy control function, okay? So basically the PCF carries all the policies within it, okay, and it generates the policies based on the subscription info of the user and current network conditions. The subscription info are the ones that are located in the UDM, Unified Data Management, okay? But the policies that they are generated in the PCF based on the UDM data for specific users, for specific services as well. So I needed to clear that point up. Okay, so going back, as we mentioned, authentication server AUSF, it handles authentication of subscribers, and also it works and it needs to work with conjunction with the UDM, Unified Data Management, because that's where the keys for different users are available. So it needs to go and send via the AMF, okay, the AMF is the one that sends the keys to the AUSF. The AUSF retrieves the keys from the UDM and it compares both so as to allow the user access or not, or even a service access to a specific or the user to a specific service or not, okay? UDM, Unified Data Management, that's the database, okay? And it has a centralized data management for different users, for different profiles, their subscription data, okay? The services to which the different users are subscribed, and the network policies for the services, okay, of these users. It connects to AMF via the N8 and to the AUSF via the N10 interfaces, okay, which is normal. As we mentioned, during authentication, the AMF will send these okay, it will request the UDM, the subscriber's data from the UDM, okay, and it will be at the AUSF where the authentication will happen, okay? So the key functions, it works with the AUSF for authentication, provides data, okay, to the AMF for access and registration, and the PCF, the policy control function, which creates the policies or generates the policies based on what? On the UDM, Unified Data Management subscribers profile. And it implements network slicing, meaning that slicing the bandwidth resources to smaller resources to to be used by a specific user. It's like creating a virtual network for a user, okay, with an independent flow control, data control, congestion control, bandwidth control, QoS profiling, okay, and it implements also session continuity preferences. I hope it's clear. Network slice selection function, NSSF. So it interfaces with AMF via N22, and it has the role of selecting a slice and AMF rerouting, okay? So it helps the AMF select the appropriate network slice for a device or a service, okay? But it is the one that creates the slice to begin with. But it helps the AMF select the appropriate slice for a specific service or device. The key functions, it maps the user equipment request to an available slice and ensures that the slice is isolated and and ensures an optimal resource usage. What's a network slice? So to go back here, what is mainly a network slice? A slice is a virtual network within the network. In other words, it is an isolated part of the connection having independent flow control, okay, bandwidth resource and latency for a specific user equipment or a service. Each slice has its own bandwidth, latency, QoS control, congestion control, independent security measures, and management policies as if it was a standalone independent network, but it's a part of the main network or the main network resource, okay? The main total network resource. A slice is created on demand, then updated, and then it can be torn down dynamically, meaning it is released from the resource pool once the service or the session is terminated. So this is the importance of dynamically creating and updating or removing a slice. NRF or network repository function. So the NRF is basically a network function responsible for registering and discovering and detecting the availability of other network functions. So it interfaces with all the other network functions via the N27 interface. So the main role is the central discovery, like a DHCP service almost, central discovery service for all other 5G core network functions, and it allows these different network functions to communicate among each other, okay? So it maintains a registry of all available network functions that are on and their respective services, and it enables dynamic discovery of these network functions by other network functions, meaning that when the AMF needs to detect the SMF, it discovers the SMF via the NRF function. So NEF or network element function, it provides a secure API interface or exposure for third-party applications. In other words, when you have edge apps or like applications that are from third-party companies that need to read some specific data concerning the network, like the geolocation or other parameters, okay, they access these network parameters via the network element function that provides this secure API exposure, okay, which is an API that is secure, okay, and does not allow, okay, an illegal entry to the network function to modify it, okay? But it exposes its internal data, okay, such as like the location or the signal power to a third-party application installed on a mobile phone. It also exposes event notifications, QoS adjustments, and different analytics, and acts as a gateway between the core network and external applications. Application function, AF, it's responsible for application traffic policies, interfaces with the PCF using the N5 interface. It hosts application level services, including service-specific logic such as the streaming, augmented reality, virtual reality, or V2X. Key functions are communicating with PCF for service-aware policy decisions to get the policy for these services, and it can initiate session setup or influence a QoS dynamically, okay? The quality of service policy dynamically. Okay, so UDSF, or unstructured data storage function. So it stores unstructured data such as application state or analytics data. Key functions, it complements the UDM, but it stores non-subscriber related information. So basically, it only stores excessive info that have nothing to do directly with the subscriber, but rather with the applications that the subscriber is using, and performs data analytics over these applications. It can be accessed usually by the NEF, the PCF policy control function, or the application function for contextual information to inquire of the application and the data usage of that application. BSF, or binding support function, it helps bind subscribers or sessions to specific instances of PCF or other network functions, so as to ensure consistent policy enforcement by linking user equipments with the correct network function instances. So that when the user equipment is linked to the correct NF instance, okay, it's correlated with that instance, and it's correlated to the session information and all the data related to that session, including the QoS profile and the data consumption for that session. So it binds the user equipment mainly to an instance of a network function that is providing the service for that user equipment. Interfaces in 5GC, so you have in service-based architecture, it uses, as we mentioned, okay, so it's function-based, and the SBA uses RESTful APIs, meaning that protocols such as HTTP, okay, this is how the SBA communicates or allows different network functions to communicate among each other through RESTful API or like something like HTTP sessions. So this is where the concept of interfaces. So the interfaces are different interfaces or different protocols, okay, between different network functions, okay. This is almost what an interface means, because the protocol used to allow the communication between AMF and SMF might be different, okay, and it carries different data type than the protocol connecting the AMF with. So reference points like N1, which is the interface connecting user equipment with AMF, it uses a different RESTful API than the one connecting the G-Node B with the user plane function, okay. That's why you have different interface names. So for each interface, you can say there's a different protocol or different policy or data being transmitted on that protocol between these two network functions, okay, where the protocol is living and carrying data among them, okay. Now, a small introduction on 5G signaling. Okay, so the signaling, the main purpose of signaling is to communicate an intention of the user equipment, or like communicate data, okay, necessary for the connection, for the data traffic transmission, okay, but it's not data related, it's not main traffic related. So as a simple example, when I call someone, okay, the ringtone signaling is not part of the call itself. It's not a part of the voice data that's being transmitted between the two user equipments that are part of the call, but rather it is a signaling that is transmitted to notify, okay, it is some type of signaling transmitted to the other party to notify him that he needs to open up his phone, okay, otherwise he won't answer the call, okay. So this is an example of what the signaling entails. One aspect of signaling is registration, or registering to a network. So what are the different steps? First of all, the user equipment sends a registration request to the AMF. Then the AMF needs to authenticate the user equipment to allow him or to allow it to enter the network, okay, to access the network. But in order to authenticate, he cannot do it on his own. He needs to get the assistance of the AUSF, or authentication server service function, okay. Now, the AUSF needs to pull at that moment the data from carried by the AMF from the user equipment itself, and then the data retrieved from the UDM for that same user equipment to compare them. Okay, so it needs to compare the keys, comparing the password when you log into any form of service, okay, on the internet. The server will compare the password that you used to log in with the password stored in the database, and when they are matching, it allows you to be logged in. The same concept here, except instead of a simple password, you have different security keys that are more complex to protect the network. So the AUSF will compare the keys retrieved from the USIM of the user equipment, which is the new SIM card, and those retrieved from the UDM for that same user equipment. From that same user identity, it compares them among each other, and then based on that, the user equipment is either allowed to be attached to the network or rejected. Perhaps he had forged the USIM card. Okay, clear? Now, 5G signaling PDU session. PDU session entails establishing a data session for a user equipment. This is what we mean by a PDU session. Okay, so basically, a PDU session entails it involves the user equipment, AMF, SMF, and UPF. How does it work? The user equipment will send the PDU session request to the AMF, which will communicate to the SMF to acquire an IP address, okay, dynamically allocated by the SMF, plus the SMF actually will send that to the UPF. The UPF will be the last anchor, okay, actually, yeah, the SMF will send the data service or the data session to the UPF, okay, and the UPF will enforce the policy generated based on the PCF, by the way, okay. It will enforce the policy, meaning limiting the data bandwidths, limiting the control, controlling the flow, okay, for the user equipment. So it's not the SMF. The SMF initiates and sends the data session with a unique IP address for the user equipment, but it is the UPF that actually controls the bandwidth and other related dynamics, okay, other related features, okay, that are related to the bandwidth. Other related like characteristics, or let's say other related parameters. Okay, so it establishes the data path and QoS for the user. Now, the handover. What is handover? Handover means when the user equipment moves from one GNOD to another, or from one tracking area to another. Okay, now you have hence two types of handovers. The intra handover, meaning that you are still within the same tracking area, but you moved from one GNOD B to another GNOD B, and inter handover, meaning that you moved from one tracking area, which is like a group of GNOD Bs, okay, having the same tracking area, to another group of GNOD Bs having a different tracking area, which will trigger a tracking area update. Okay, so the 5G signaling handover also maintains the session, which is the data session, by rerouting it either to a different GNOD B when you have an intra handover, or to a different tracking area than a different GNOD B under another tracking area, okay, rerouting the data session to another tracking area on one hand, and also to the other GNOD B which is a part of that new tracking area, okay. But it will guarantee the maintenance or maintaining the data session, okay, and the continuity of mobility, okay, the data service continuing while the user equipment is moving. So finally, the future trend is the 6G. We can talk about the AI, which will be integrated, okay, with the 6G network, machine learning concepts, etc. So this is mainly the 5G core network and a part of explaining the signaling in the 5G network.